In this segment, we're going to talk about the inverse square law. The inverse square law is a law that tells us that the quantity and strength will decrease with the square of the distance from the source. So what we mean by quantity is a number, such as 1, 3, 101. And what we mean by strength is an effect or a property, such as gravity, or such as brightness, such as the brightness of a light bulb or the brightness of a star. And the key word in this law is the word decrease. So as you step away from your source, which in this case may be a light bulb, the brightness of the light bulb will decrease. And that is the inverse square law. Let's look at an example. So here we are looking at a light bulb. And this light bulb is round, so it's going to radiate into a sphere. And that light is going to keep spreading out. And so let's look at another sphere. But it makes it too complicated to look at a sphere, so we're just going to look at a hemisphere. And on this hemisphere, we are just going to look at 1 square meter. So it's a square on the hemisphere, and one side of the square has the length of 1 meter, and the other side of the square has the length of 1 meter, so that the area has 1 meter squared, or 1 meter times 1 meter, or length times width, and that gives you 1 meter square. Now, just by chance, we are located at a distance of 1 meter. And this light from the light bulb is spreading out in all directions and is passing through this 1 meter square on this hemisphere. So let's call the brightness at this 1 meter hemisphere B1. And it is the brightness of the light that is passing through this 1 square meter of the hemisphere. Now let's double our distance and go out to a hemisphere of 2 meters. So we went from 1 meter to 2 meter, or we doubled our distance. So the word double means 2. If we tripled our distance, triple means 3. If we quadrupled our distance, that would mean 4. But let's just look at double. So we're going to double. So let's just look at double. Double means 2. So we doubled our distance out. What will the brightness be now passing through this hemisphere? So we want to find the brightness at 2 meters, or B2. The brightness of B2 relative to B1. Well, the light continues to spread out. It passed through the inner hemisphere at B1 and is now going through the hemisphere of B2. So the portion that passed through the square in B1 has spread out to a larger square at 2 meters at the 2 meter hemisphere. So as we can see, there are 4 blocks now at the 2 meter hemisphere. So there was 1 block at the 1 meter hemisphere, and now there's 4 blocks at the 2 meter hemisphere that the light is now passing through. So the light has spread out, and since it spread out over a larger area, it became more dim. So if you were standing here at the hemisphere of 2 meters looking back at the light source, it would be much dimmer than if you were standing at 1 meter looking back at the light source. And this is an example of the inverse square law. Now, how do we know there are 4 blocks at 2 meters and only 1 block at 1 meter? Well, at 1 meter, we are looking at a 1 meter square block on the hemisphere. And we doubled our distance away. So we went from 1 meter to 2 meter. But the inverse square law says it's the square of the distance. So since double means 2, the square of the distance is equal to 4. So we doubled our distance, and therefore the square of the distance is 4. Now the key word here is decrease, so we know the brightness has to go down. So let's look at the key word inverse here. So the brightness at B2 has to be much less than the brightness at B1, and the inverse means that this 4 is in the denominator and a 1 is in the numerator. So the brightness at B2 is 1/4 the brightness at B1. And this 4 also means that we have 4 blocks here. Now let's say we don't look at the square at 1 meter and we don't look at the square at 2 meters, but let's say we create a hemisphere at 3 meters. So we're going to draw another hemisphere here at 3 meters. And we want to find the brightness at the third hemisphere compared to the brightness at the first hemisphere. So what is B3 relative to B1? We know that the light spreads out. So we know it's going to spread out even more. And we're going to find a block that it's going to pass through. And the block is going to be 3 meters in width by 3 meters in length. And so the area is going to be 9 meters squared. So this light bulb that passed through a 1 meter square, or 1 block at 1 meter, passes through and spreads out into 4 blocks at 2 meters, and then the light spreads out even more into 9 blocks at 3 meters. So let's look at the word quantity and decrease. So we know the brightness has to decrease, and we know we are looking at the word triple. We tripled our distance. Triple is 3, and the square of the distance is equal to 9, so that explains why we have 9 blocks in our square on our hemisphere. And the decrease and the inverse mean that the 9 is in the denominator, so the brightness at 3 is going to be 1/9 the brightness at 1. So the brightness, when you tripled your distance, if you were standing here looking back, the brightness of the light bulb will be 1/9 as bright as if you were standing at the inner hemisphere looking at the light bulb. So here's another example of the inverse square law.